My name is Jay Graham. I am now retired. I worked for the University of Pittsburgh in the Central IT department in Pittsburgh, Pennsylvania for 40 years. I retired last August. I now teach a couple of classes in computer science at the University of Pittsburgh. And as you can see, I am with the Blue SCSI team here in the Explorer Hall, demoing and selling some of the Blue SCSIs. Enough about me. I'm not here to talk about me today. What I'm here to talk about is the Z80. And I titled this slide, The Apple II's Secret Operating System, because it's a lot of people know about it, but they don't know a lot about what it can do, how it came into being, and those types of things. Most people think that it's the 6502 machine. It's a hobby machine. I can program in 6502 assembly language. But it also has a secret side, which is the Z80. Microsoft, and we'll talk a little bit about it today, Microsoft was the first one to develop a Z80 card for it. We'll talk about how that came into being, and then after that, a lot of other companies followed suit in that. And I have one, that was the SPAOE one. Whoops, what's this thing here? It's almost time to restart. No, not now. Security updates. So this is a very good knockoff of the Microsoft SoftCard. So I'll pass this around, as we get started here. So I want to kind of explore the lesser known option today, which is the Z80 or the Z80. And it was one thing that turned the Apple II, an Apple IIe into a business machine. There was a lot of business software, and we'll talk a little bit about what software was made for it today. So the topics that we're going to talk about is just basically a brief history of the Z80. Where did it come from? A little bit of a history about CP/M, the Apple CP/M card solutions that are available. I gave this talk at Kansas Fest probably about 6 or 7 years ago. Since then, I've had to update it because there are some new hardware solutions out there for CP/M for the Apple. And then CP/M software, there's a ton of it out online, and I have some things in here where to get it. There's a QR code here that if you guys scan, it's a OneDrive QR code at Pitt. It'll have this presentation, and it'll have some CP/M software on there, and all the links to where to get CP/M software are in this slide. And then I'll do a little demo here. I was planning on bringing my Apple IIc. I have that in the car with the HDMI connector on it, so we could really do it on real hardware, but it just didn't work out. So we're going to do it on Apple Win and do some emulation here. Most things should work. The things that do not work is utilities that talk directly to the hardware, obviously, because it's an emulator. All right, so let's talk a little bit about the Z80 CPU and where this came from. It was designed in 1976 by a gentleman named Federico Fagin, and Federico also worked at Intel. He also did some development on the 4004, which was the first 4-bit microprocessor that Intel came out with, and also the 8080 processor. He did a lot on that. His design was fully compatible with the 8080, which meant that any existing software that ran on the 8080 would work on the Z80. And this was a huge advantage at the time. The Z80 then was licensed broadly. Zilog, he worked at Zilog, by the way. Zilog then licensed the Z80 broadly to companies like Cinertech, I think, was one. Mostech was another one. The same people that made licensed the 6502, the Mostech. This one, I believe, if we look at this one, this is a Cinertech on here. There are some that were made in Italy, so they licensed it to Italy. Federico, obviously was Italian. So it quickly became affordable and widespread. With the Z80 processor. And compared to the 8080, it added some more registers on it, which we'll look at here in a minute, had a denser instruction set, And it wasn't just for personal computers. It, by all means, it went in a lot of personal computers at the time, but it also went in embedded devices and devices like video games. And it's still popular today, believe it or not. Actually, I think Federico didn't work at Zilog. He worked at Fairchild, because Fairchild was the one who was making all of the chips. Back then they made 95% of the ones for the Apollo program. And again, it was an improved design over that. Gentleman on the left is Federico. The gentleman on the right is Chuck Peddle, who we all know worked at Moss for MOSTEC, and was kind of the designer of the 6502. And again, he began to champion this design and the Z80 design, because it was a lot less expensive than the Motorola 6800, which was about $300 back then. And Federico was involved in a lot of the layout work for the Z80. And I have a silk screen of it here, and we'll see what it looks like here in a minute. He worked 80 hours a week for weeks on end on the design and the layout of this in order to meet the tight schedule that was given by the financial investors at Fairchild. And if you remember, Bob Noyce and Gordon Moore worked at Fairchild, along with some of the other people that left Shockley Semiconductor. So they worked there too. But at this time, they were at Intel. When Federico was doing this. I'm not going to go deep into the registers on the Z80. There are 252 opcodes. There were 8-bit registers that were typically paired up to make a pseudo 16-bit register. It has a unique fetch execute, overlapping, and it has a set of undocumented instructions like most microprocessors had at the time, and it had bugs like a lot of the microprocessors, had at the time. And again, the thing that it made it easy to program. It was a lot easier, at least in my opinion, and other people's opinions too. It was a lot easier and more flexible than the 8080 at the time. And it came in a DIP 40 configuration, which we'll see here in a minute. This is the silk screen layout of the Z80. I didn't blow it up anymore, but this is what the silk screen layout and the design of it looked like, with all of the transistors that are on there. And again, this is what the package would look like. It was a DIP 40 package, and the pin layout, is over on the left there. 16-bit address register, 8-bit data register, obviously had the reset, refresh, the clock signal, and the VCC and ground. So again, he wanted to make this to be binary compatible with the Intel 8080. Comparing the 6502, MOS 6502, and the Zilog Z80, these are the pinouts of both of the processors. They're nothing alike, but again, I just wanted to compare this to show you the difference between the processors. The 6502 was a little bit simpler. It was a little bit less expensive, although the Z80 didn't cost much more than that at the time. And the 6502 was used for hobbyists and educators, game developers. That was like the processor of choice for that. The Z80, on the other hand, it was more sophisticated, and because it could run CPM, and we'll talk about CPM here in a minute, it gave access to a huge library of software, professional software. And again, we'll see some of that here in a minute. Here, I have some of the categories of the CPM software that's available here. And it brought more of a serious side to the Apple II. Dan Bricklin, eventually they released a version of VisiCalc that was a CPM version, as well as the 6502 version of that. So it kind of gave the Apple users the best of both worlds. Now, obviously, the Z80 was used in a lot of hardware back then. Again, and it's still used in embedded hardware. Coleco used it in their ColecoVision, the video game. Radio Shack obviously took advantage of it. K-Pro, MSI, Osborne, MITS, the Timex Sinclair. The one there that the yellow arrow I'll show you on the next page. I'm not going to tell you what that is. Some people may recognize that. Commodore, you could even get it for the Commodore 64. There was a card that plugged in the back. Heathkit, and obviously Xerox. Xerox used it. The one that has the arrow over it is the BBC Micro, the Acorn computers. They definitely ship with the 6502 in them, but they used what was called a tube interface. It was a 40-pin IDC interface that you could add a second processor in there, which was the Z80, so it would run CP/M as well. You know, again, this is one of the machines that you had best of both worlds. You could run 6502 software, and you could also run the CP/M software. So let's talk a little bit about the history of CP/M. CP/M, you know, eventually stood for Control Program for Microcomputers. I forget what the original thing it stood for, but they eventually changed it for Control Program for Microcomputers. It was created originally for the Intel 8080, which we know was in the MSI and the MITS Altair, in the 8085. The gentleman that created it was Gary Kildall. Now, Gary Kildall founded a company back in the early 70s, 73, 74, called Intergalactic Digital Research. He was in the Navy, left the Navy and founded Intergalactic Digital Research with his wife, Dorothy McEwen. And CP/M was the software that he developed at that point, and it was a lineage he used. There was MPM, and then eventually he wrote CP/M. Now, it was a single tasking, 64K of RAM, 8-bit, and as I said, like the MITS Altair was definitely, and it was displaced early, by MS-DOS in the 80s, and I'll get to that here in a minute. But back then, CP/M was the operating system. It ran on everything. And there was a reason for that. It was very easy to port from one processor to another, or one system to another. And I'll explain why that was here in a little bit. But again, here's a picture of Gary Kildall. He was born in Seattle, Washington, with the irony of that, where Microsoft is. He attended the University of Washington, and he was pursuing a degree in teaching mathematics. He worked as a consultant at Intel. Matter of fact, the first device he wrote CP/M for was the Intel Intellect, Intellect 8, which I'll show you here in a minute. And he developed this from MPM and PLM, created the CP/M out of that. He demoed CP/M to Intel. They had very little interest in it at the time. And they chose to market PLM, which was his high-level programming language instead. Later on, Intergalactic Digital Research just was digital research. Later on, that was sold off to Novell. I was a big Novell person back then. DR DOS, or Dr. DOS that everybody called it. And then eventually Caldera bought it. And now I don't think they're around anymore. But by 1982, CP/M was running on roughly 3,500 different hardware platforms. Apple was one of them. And I think everybody knows the story with Gary Kildall. IBM was, developing Project Acorn, or Project Chess. Acorn was the code name for the IBM PC back then. They went to Microsoft at the time because Microsoft was developing a lot of the programming languages back then for the systems that were out there. And they asked Microsoft, hey, Bill, can we license the programming languages for you? Sure, absolutely. You can have them all: Fortran, Pascal, Assembly, Basic, all of them. You'll be able to license all of them for us. Obviously, when we want a license per PC. And they said, well, you have an operating system for the 8080. And he goes, by golly, I do not. However, and we're not doing operating systems. They weren't doing it back then. So he goes, by golly, we do not. He goes, but I know a guy. And they pointed him to Gary Kildall, who's out in California. IBM went out to California. As the story goes, Gary was out flying his plane. He wasn't out flying for recreation. There's a lot of myth to this. He was out flying it on a business trip. and his wife, Dorothy McEwen, answered the door. Now, she always went by Dorothy McEwen because she didn't want to be known as just Gary's wife. So she went to Dorothy McEwen. She was an integral part of the business. IBM said, hey, we got this thing we're developing, Project Acorn. We want an operating system for it. We heard Gary and you are the ones that are writing the premier operating system. Yep, we are. They came out with a non-disclosure agreement because this thing was as top secret as like the Manhattan Project. IBM didn't let anybody know about it. Microsoft, when they were developing languages for it, had a room there that was locked. IBM would audit it. They just didn't let this thing out at that point. So they wanted her to sign this NDA. She wouldn't sign it. She talked with her lawyer. She wouldn't sign it. IBM walked away pissed off and went back. Now, eventually they did meet with Gary Kildall, but Gary wanted, again, a per license agreement like Microsoft had for their languages. But again, IBM said, gee, this is going to be sold with every PC, and we're going to sell millions of these PC. We don't want to pay a per licensing fee. We want to do a one-time cost for this. And Gary argued back and forth with them, and finally they couldn't reach an agreement, and IBM went, pissed off back to Bill Gates. And they talked to Bill Gates, and they said, hey, Bill, he wants, a per licensing agreement, costs are too much. You sure you guys don't have an operating system? Well, oddly enough, Paul Allen knew a guy at Seattle Computer Products. It was a small company in Seattle. There was a good gentleman there by the name of Tim Patterson, and he wrote Quick and Dirty DOS. Now, CP/M at that point wasn't running on the 8086 or the 8088. They were working on it. Digital Intergalactic Research or Digital Research was working on it, but they didn't have it running on that processor yet, which is what the IBM used. The IBM used the 8088. So Tim Patterson, oddly enough, wrote a knockoff of CP/M, and he called it CP/M 86, or it was a CP/M 86 kind of lookalike. It wasn't called CP/M 86, but it was called Quick and Dirty DOS or QDOS. So Paul Allen knew this gentleman, and Paul said to him, they said, hey, we need an operating system. Can we look at CP/M 86? Well, Tim Patterson, demoed it for him. And they said, wow, this is just what I want. $50,000. They bought it from Seattle Computer Products, one-time cost, licensed it from them. They worked months and months and months, and they developed PC-DOS 1.0, and then MS-DOS eventually, with that. They went to IBM, and they said, we have a DOS for you. Didn't have it yet. They were still developing it. We have a DOS for you, but we want to license it per PC. Well, IBM had their backs up against the wall because it was it was about 18 months before the release of Acorn and the IBM PC. So they said, sure, yeah, we'll license it for you. It was $40 a copy back then. Now, Gary Kildall, sued and said, you guys need to sell CP/M as well. I have CP/M 86. But it was $240 a copy. Well, you know what happened at that point. IBM included PC-DOS with the bundle with the computers, and that's what shipped, and that's made Bill Gates, a quadrillionaire. But again, CP/M was definitely, an operating system in play back then. But nobody that bought the PC was going to pay $240 for it. They were going to use PC-DOS at the time. So that's kind of the Cliff Notes version of that story on how DOS, came on the PC and how CP/M didn't. Had it been different, who knows? Again, it was developed in '74. It has a large library of software. DOS actually, because they used, the CP/M 86 clone QuickDOS, it inherited a lot of things like drive letters, wildcard names, 8.3 file names, device names like PRN and CON, and obviously the Control-Z, all of that came from that. This is the Intel 8, which CP/M was first developed for. It was developed this was a kind of a testing box that Intel used back then. Gary Kildall and his team worked to develop and interface it with a Shugart 8.5-inch drive, which is down in the lower right here. And that was a custom floppy disk controller. Now, why was CPM on a lot of hardware back then? Well, the way that this was designed is that there were three components. There was a BIOS, which was a basic input-output system, not like it's again similar to the BIOS that we have on the computers, but this was part of the operating system. There was the BDOS, which is the basic disk operating system, and then the console command processor, or the CCP. He even came with a debugging tool called DDT, dynamic debugging tool, but it was DDT, which was pesticide back then. Why it was so easy to port was because the BDOS and the CCP didn't have to be changed from hardware to hardware. It was generic. Okay, it was hardware agnostic. The only thing that you really had to change was the BIOS. And that was what interfaced the operating system with the hardware. So as a result, it was very easy to port CPM to a lot of these areas. And it had a TPA, which was a transient programming area, and it obviously had low storage like a lot of operating systems do, with system buffers and parameters and so forth. Now, what software was available for the Z80? Well, there were a lot of commercial software titles available back then. Microsoft had COBOL, Fortran, as I mentioned, assembly language, for that, and BASIC. C Basic and M Basic, Microsoft had a BASIC that was for it. C Basic was one of Gary Kildall's grad students, Gordon Eubanks. He went on to found Symantec or whatever. Well, he wrote C Basic back then for this. Aztec C, Borland, Turbo Pascal, or a few Pascals available. Modula 2, Borland had a Modula 2 for it. Janus had an Ada compiler for it. And then Mumps was even. How many people know Mumps and never heard of Mumps? Few people, yeah. So I had a friend that used to program in Mumps. So there was a lot of high-level languages that were available. There were also a lot of commercial titles for it. Word processors. WordStar was probably the very first word processor that was on it. That's what I'm going to demo today. Tex, TMaker, and then Magic Wand word processor. A lot of databases that were available. dBase 2 first came out on CPM. What's it, which is basically an acronym for wow, how did all that stuff get in there? Lyle Morrill made that. That was a free-form database, kind of ahead of its time back in 1975. It was pretty clever back then. And then obviously Microsoft with Multiplan and SuperCalc. And then there were even games for it. Zork, Nemesis, Sargon, Chess, which probably ran on every single platform in the entire world. And then there were a lot of basic games for it, okay? Now, the version history of CPM, the first public version that was made available was version 1.4. And then there were versions 2.2 and 3.0. These are from Digital Research. Apple had some unique versions because Applied Engineering made a card for it, and they had CPAM 4.0 and 5.1. I think I'll be running 5.1 in the demo here today. And those obviously had ProDOS support for the Apple. Command comparison for those people that know DOS. There's a lot of lineage in CPM that came from DOS. Now, one thing I wanted to note here, you'll see the asterisk at the bottom. Some of the commands, in CPM were what we would call intrinsic commands, or they were built in to the CCP. Other ones that don't have the asterisk beside them, like ed, pip, and submit, were external programs. They were still commands, but you had to have a COM file on the disk that you were running this from for those to work. Now, I'll show you pip here as well. Notice that there's a dir, the type, ed and edlin, ERA for erase and delete, pip and copy. Notice that on pip and copy, we had to switch the source and destination just because. Rename. Submit was how you ran a batch file in CPM. It was a sub file. And then you obviously just ran the batch or command in there. It didn't have, at least the first few versions of this did not have subdirectories, but it had something called a user space. So you had a user space, I think it was from 0 to 8, if I'm not mistaken. So you would do user 0, and then any files that you would create, or user 1, sorry. User 0 is the base by default one. User 1, and then any files that you created in that context of user 1 would only be viewable by you. If you went back to user 0, you wouldn't see them. You would inherit everything from user 0, but you wouldn't see, user 0 or user 2 or user 3, that when you change to that user space, you wouldn't see anybody else's file. And then there was a stat on there, which was basically a quick disk check. It was kind of like check disk, kind of. Check disk had a lot of things for checking for bad blocks, which stat did not. Okay, so why the Apple II? Well, Paul Allen had an idea that said, hey, we can automatically just double or maybe even triple our software by building a card that would fit in the Apple II that would run CPM. Oddly enough, it was developed by Tim Patterson. Remember Tim Patterson? Guy who wrote QuickDOS? Microsoft hired him. Ironically, he worked on the Z80 card with Bill Gates in designing the hardware for this. And Don Brutus, I think it was, designed the soft card. He was, was it Bertronics, I think was the place. Anyway, they designed a soft card, for Microsoft at this point. But again, Tim Patterson and Bill Gates worked on, the operating system and porting the operating system to it. This was like one of the biggest sources of that revenue for Microsoft in the early 80s, in early 1980. I think they sold 5,000 units of this soft card in like the first 3 months, and they were like $349 list price in 1980, which is like $1,000 in today's dollars. So again, the idea for this came from Paul Allen, so that we could suddenly triple the software for the Apple II, and it worked. They showed it at the West Coast Computer Fair in 1980, and it was a hit. As I said, 5,000 sold in the first 3 months. So the Apple II then wasn't just a machine for the hobbyists in schools anymore. A lot of businesses were buying this. And again, remember, Dan Brickland ported VisiCalc to this. Okay, this is the soft card. I'll go ahead, and if somebody wants to just pass this around, you guys can pass that around and take a look at it. That's a knockoff. It's a really good knockoff. And again, everybody knocked off the Microsoft soft card. This is the official Microsoft soft card. There's the Z80 processor in there. It's a Cinertec, the same one on the card that I'm passing around. It had a bank of 4 switches on it. Normally, you did not have to touch these. They were all off. If you did need to touch them, what you would touch them for is 1, disabled the address translation. 2 was a higher priority DMA. Switch 3 would allow you to pass the NMI line to the Z80, and 4 would let you to pass the IRQ line to the Z80. Again, you need it for very special purposes. Most of the time, all switches were down. You plug this baby in, you get to boot it with a CPM disk off the same Apple II disk drives that you booted ProDOS or DOS 3.3, and voila, you were in CPM. Now, there were 2 types of cards that were made back then, and I've since added a third. So the first type of card was a soft card style, and it was like the soft card. Microsoft was the first to produce it, a lot of knockoffs on it. Basically what this did was it suspended the 6502 via the DMA line, okay? It took over the bus, and it had direct access to the Apple hardware, okay? So that card had direct access to the disk drives, the console, and those types of things. And there were a lot of cards. I'll show you some examples here. Obviously, Microsoft was the first. Applied Engineering came out with their Z80 Plus. A modern version is Ian Kim's Turbo 7. And there are a couple of other modern versions that are the soft card, variety here. The second type was called the SBC, or the single board computer. Now, this functioned independently of the 6502, typically had onboard RAM. You would have 64K on board, minimum of the card. They clocked the Z80 a little bit faster, okay? The soft cards were clocked at the 1 megahertz. Here, they clocked the Z80 a lot faster. They would clock it between 4 and 6 megahertz. These obviously ran CPM software a lot faster. The drawback is that it had no direct access to the Apple hardware. You had to write the entire interface to the Apple hardware for this. And these plugged usually in the aux connector of the Apple IIe, which was one of only very few cards that used the aux connector for the Apple IIe, or it would plug into a normal slot as well. And there were most of the people that did these were PCPI, Personal Computer Peripheral Incorporated. These are relatively expensive cards. AppleCard, they were usually bundled with WordStar and MicroStar. The CPM Premium SoftCard and the SoftCard IIe, that went in the aux slot. And then ALS, or Advanced Logic Systems, came out with a CPM card that would fit in the normal slot. That's all we had for a while. Well, enter Type 3. This is the software-defined Z80 card. Now, lately, we've been seeing some of these where they're emulating the Z80 CPU on a Raspberry Pi. There's a couple of A2 VGA cards out there that you can run the Z80 set. It emulates a PCPI, by the way, card, the one on the top here. It emulates that. It's a bus interface board. It's reconfigurable via software, since software defined, and it allows the Z80 emulation to run much faster than the original hardware, which is really cool. It runs even a lot faster than the 4 megahertz clock stuff. And it maintains compatibility with the Apple II's timing signals. There are a few of these out there right now. Here's a picture of one that I showed there. That's a VGA card that doubles, or you can configure it to a Z80 card. Now, a lot of people are saying, hey, I have an Apple IIc. What about that? Well, Applied Engineering, and there were some other vendors too, but Applied Engineering was far popular. The top one is what my Apple IIc that I was going to bring today has in it. It has the ZRAM Ultra 3 on there, had a battery backup, had the Z80 processor on it, had some memory on it, a real-time clock, had the whole works on it. And then they had the Z80C, which was another board that plugged into the Apple IIc. So how do I get started on Apple II CPM? Well, basically, you choose your hardware. If you want to run an emulator, you want to run one of the software-defined ones, or you pick up one of the either the SoftCard variety or the SBCs, and you can plug that into your Apple II or Apple IIe. Find one of the ZRAM Ultras. Somebody's making one, I think, for the IIc, or they may have already made it for the IIc, a modern one that'll plug into there. These used to be terribly expensive, but now, since the software-defined ones are coming out, you can find them relatively inexpensive on eBay. I have probably 20 of these different varieties of these at home and collect CPM cards. Get the correct version of CPM for it. Most of it will run most of these emulators, like that one that I was passing around, will run the SoftCard CPM. PCPI has a different version of it. Applied Engineering has a slightly different version of it as well. You make boot disks with pip. You'll have a boot disk, but you may want to move some more utilities over on it. So you'll use pip to copy those utilities over. Download some of the software. Some of the software is ready to go for the Apple II disk drives, and you just put it on there. But literally, you can download any CPM software program that's compatible with the Z80. And if you can get past the media barrier, meaning if you can get it onto a emulator or a floppy, it'll run on the Apple II mostly. And there are hard drive versions out of there. The PCPI has a way that you can patch it and make like a hard drive version, and you can run all of your CPM utilities on there. When I tried this last, it was about 7 or 8 years ago. There was one utility that was missing that you had to have, and the disk was corrupt. I don't know if they've changed that or fixed that now. And then obviously read the CPM user's guide. I'm going to go ahead and stick this up at the end here, but I will go ahead and I want to do a quick demo of just some of the CPM software here. Let's see, is my mouse there? Yep, it is. Let me go ahead and turn this back to duplicate so I don't have to keep dragging it over onto that screen. I'm going to use Apple Win. Most everybody who has an Apple II has probably seen this. So I'm going to boot it. Yes, I'm running it a little faster than the 1 megahertz, but it booted with the CPAM. This is version 4 for Applied Engineering. And obviously, I'm just going to do a directory, and there we go. That gives us a directory. The numbers beside the file names are blocks, not K. They make a utility called SD that's on here that if I want to see what the difference of it is. I'll go over to the B drive. I'll do a directory on the B drive. And you'll see that this has WordStar on it. So I'm going to go ahead and run WordStar on this. And bring you back 40 or 50 years to the version of WordStar. And I have a couple of documents on there right now, like sample. I'll go ahead and hit D. I want to go ahead and open that sample document. And voila, who remembers their WordStar commands? I had to, I had to get the cobwebs out of there because, yeah, these are the WordStar commands. So, and again, you Control KS, boom, it's going to save it. Control KQ will abandon the file. At that point, you know, I can run a program in here. I can exit. I can run mail merge in WordStar, rename a file. I have all the file commands and some of the preliminary commands. And then there's a, you know, an 8.5 by 11 sheet on there. Now, one of the things that I wanted to show you was the user ability on here. So if I go user 1, you'll see a little A that comes by that B. That's indicating me that I'm in the user 1 area. Now I'm going to go ahead and pip something. Let me see what's on the A drive that I can pip over here. Is there a small file on there? I'll do SD. So when I use pip, I got to do, I'm going to do B colon. There's many ways to do this. Equals a:/sd.com. Okay. Destination equals source. It will take a second, and now you should see. Do I have the SD on there? Is it on there somewhere? Yeah, there it is. SD over there on the A. Now, watch when I go back to user 0 and I do a directory on here. You don't see the SD on there. Okay, I go to user 1. So this is like the poor man's subdirectories on there. It's back on there, and you'll see a little A prefixing that file name. I can go ahead and run it. You know, on there, you know, there's just sd.com. Even though I see all the other file names that are in the user space in there, the SD is only going to give me the directory of the ones that I have access to. Okay, let me go back to user 0. I'll go back to A. Let's see, is there anything else I really wanted to show you? You'll notice that the extension with COM there, those are all the programs and the runnable programs. You'll see format on there. You'll see there's a RAM drive on there. So not only did it support 64K of memory on there, you could carve up some of that 64K and run a RAM drive on there. Now 64K doesn't seem like a lot, but NSweep, which is a very, very sophisticated program, it's using 12K. Okay. CPM 60F, it's using 13K, you know, on there. But you'll see most of the program files are under 10K, you know, that are on there. Turbo Pascal was made available for this. It came on 2 disks. You know, jockeyed it around until you build a system disk on there, and you can compile Pascal programs on there. Like I said, VisiCalc and all of those things on there. Is there anything else I wanted to show you here? I don't think so. I think that was it. So let me go back to this, and I will go ahead and put that QR code up there. So that goes to my OneDrive site that has some of the OSs on there, some of the software on it, and it has this this presentation, which the presentation, the last slide here. Let me flip here. Hold on one sec with this. It has a lot of sources to get CPM software and read about CPM. You know, on the Apple II, and that's basically my talk. Does anybody have any questions? Yeah, in the front row there.
Did the other users get like subsequent like user 2 or?
Yeah. Hang on here. Let me show you. So if I went to user 3, would it be C? Is that what you were asking? Yeah, it will. So let me see if I can show you that here. Here, we'll boot CPM super fast again. Boom. So yeah, if I do user 3, it's a C. Huh? What they did is they didn't have subdirectories back then. So if they had multi-user machines, because again, some of these were, you know, on hard drives. Oh, who knows? I don't know why they did that. That would be a good thing to research. But as you can imagine, if you go to, let me go back to user 0 here. I think I can just go to user 4. It's D. What do we think user 5 would be? E. Huh? Per disk, yeah. Yeah, you would do that. Now, if I'm user 5, I can copy files to this disk. It's going to take up space. It's not going to give me any magical space on there. But if I'm user 2 or user 1 or whatever, then, you know, I won't see that file. It's basically, and there's not a lot of security, right? There's no password here or anything like that. But it was a way so that people could have their own user spaces on the floppies. CD was, you know, eventually is what became of that when we were in DOS. So, yeah.
User like subsection have like its own file limit?
Oh, that's a good question. So yeah, the question is there a number? There is a hard ceiling of the number of files that you can have, like on a 140K floppy or on, you know, on the Apple II. They all count. So it's just like this. It's no workaround. You're not going to get magical free space on the disk. Just like when the disk is, if user 5 goes on there and there's a disk piggy and fills it up, user 0 and through user 8 are screwed. Or 15 maybe, I think it is. Yeah.
Could you jump directly from user TEA to DB?
Yeah, so if I wanted to jump, I think it's 15. Let me see if it's user 15. Yeah, user 15. I'm now on user 15. If I do a directory, I'm going to see everything. Well, here on the B drive, let's go over to the B drive. I'm going to see everything that user 0 would see, but you don't see that sd.com on there anymore.
Well, I'm asking, can you jump user and disk at the same time?
Oh, no, user. Oh, I think I misunderstood your question. When I go to that user space, that user is in the CCP in the command processor. So now when I'm on B, I'm writing in user space 15. So it's not on per disk. It's basically you're in user space 15. Wherever disk you go, you're going to write on user space 15 on there. So I'm sorry, I misunderstood your question until he clarified it. Yeah.
So it's just a concept.
It's a virtual concept to kind of give you your user space on there. Yeah. Why they did it, I don't know.
Probably had a couple of 3 bits.
Yeah. Hey, let's use them. 3 bits on there. Yeah. Anybody else have any questions? Yeah, in the back. Say networking. A question is, was the network stack ever developed for this? That is a good question. I do not know the answer to that. There are obviously were devices in there, like CON was serial, PRN was printer. So it had the DOS device-like things on there. That's a good question. I'll look into that and I'll post that up on the OneDrive. I'll post a little thing up onto there. Yeah, that definitely, concurrent DOS and Dr. DOS. But they were more DOS-like. They weren't, you know, they got some lineage from CPM. But yeah, that's a good question. Yeah, well, it would. It would. A lot of this was way before the internet, but not way before networking. So yeah, let me look into that, and I'll post a little update up there. Yeah, question back there. Serial. Oh, all right. So it was like network by proxy. So you would be connected through an RS-232 or 422 serial connection, and then the mainframe would have the TCP/IP stack on it, and you would use it that way. Thank you. Yep. Yeah.
How common was it for you to be able to, for certain CPM applications, to utilize the Apple II peripherals? Like the single board computers, they seem like it's basically the advantage is you have 2 computers in the same case. Type 1 is interesting because it owns less and use the Apple peripherals.
Yeah, there were a lot of Apple peripherals you could use for it. Not everything, but like the floppy disk drives you would use. The super serial card was usable in there. Modem, yeah, you could use a modem on there. There were a lot of Z-Term and there were a lot of terminal emulators, you know, that were made for it. So yeah, you could use a lot of that. Haze, I think that was COM. It was COM was the device for that. So if they wrote a device driver for it, you know, within CPM or a utility, you know, for it and wrote to that hardware in that BIOS section of the, or patched the BIOS, some of them, you know, like the PCPI card, if you want to use some of the peripherals, you have to patch the BIOS actually on the CPM, and it'll actually run in there and patch and update the BIOS, but then it'll be able to use peripherals. I don't think it was everything, but some of the most common ones, yeah, you could definitely use it. Yeah. Any other questions? Sure. Yeah.
Kind of like an extension to that. Was it possible to transfer data between CPM and like Apple?
Yes, there was. Now, what's that? Oh, repeat it. Yeah, the question was could you transfer between the CPM operating system and the Apple operating systems? The PCPI card you actually got ProDOS disks with that. So that, again, that was the single board computer type. You could do the transfer pretty easy because it knew what ProDOS was at that point. Now, DOS was a little bit harder. You could still do it, but you had to use some funky serial communications and things like that, you know, for some of those. But some of them had, a lot of the cards came with direct ProDOS, you know, ProDOS capability on it. So thank you for reminding me to repeat the question too. Yes.
Assuming you couldn't take a disk out of a Altair or anything else.
No, that was the file system part of it. That was the part that was on there. And that's kind of what I mentioned. The question is, what file format were they using? Everybody had their different file formats. Some of them were the same. So that's why I was saying there's a lot of CPM software out there, you know, the COM files, but you need to get it onto the Apple formatted CPM drive to be able to use it. So they were all different formats. If you put a CPM disk in a ProDOS, when you boot ProDOS and you do a directory, you get a bunch of colons. So, you know, there is a file system on there. It's just not compatible with that. But like the PCPI card, you could actually, you know, read CPM disks directly from ProDOS with the utility that they gave you. That answer your question? But yeah, everybody, and again, remember, it was back on the 8-inch discs too. So, you know, the file format, those were 140K or 120K or whatever, single density. So everybody kind of did their different file format, but you could get around that via, like you said, serial. You could dump it up somewhere and then, you know, pull it down. There are a lot of terminal programs for it. Kermit, there was even a Kermit for it. It's called Kermit, what was it? Kermit PM or whatever. Anybody that doesn't know what Kermit was, that was like a big terminal emulation program in academia back in the day. But yeah, they even wrote a version of Kermit for it, which is what I used to dial into the University of Pittsburgh when I was a student there. The Hayes modem, 1200 baud. Ooh, that was something back then. Anybody else have any other questions? All right, well, thank you. Thank you, everybody.